Okay, team, let's cruise ahead with observational learning. So just a reminder, right? We talked about behaviorism, and there are cognitive processes within both classical conditioning and operant conditioning. So cognitive processes, meaning how we think, what we think, and how that impacts our behavior, right? In classical conditioning, when the dog salivates at the bell, it may be due to cognition, right? Learning to predict or associate that the bell is telling you that the food is coming, right? We also know conditioned responses can alter attitudes even when we know the change is caused by conditioning. However, knowing that our reactions are caused by conditioning gives us the option of mentally breaking the association, right? So like kind of this like meta explanation here, like if we know that we've been classically conditioned to salivate when we hear the sound of a bell, we're pretty quick to realize that and like tell ourselves, oh, the bell isn't what we're looking for, the food is what we're looking for. So there is cognitive processes, especially for human beings, in terms of overcoming things like classical conditioning. The last piece here, right, higher order conditioning involves some cognition, right? The name of a food may even trigger salivation, right? We have to make those intentional connections. If you remember back to higher order conditioning, and we talked about the guy who coffee brings him joy, and therefore a restaurant that serves him coffee every time he goes in now gives him joy, right? He's thinking about that and making that connection. Then to shift over to operant conditioning and the cognitive processes that exist there, we know that in fixed interval reinforcement, animals do more target behaviors around the time that the reward is more likely, as if they're expecting the reward. So they're pretty quick to kind of interpret the amount of time, that interval between their reward, and they are more efficient at doing it closer to the time they're going to get a reward. We know that expectation as a cognitive skill is even more evident in the ability of humans to respond to delayed reinforcers, right? That's us thinking like, yeah, I'm recording this lecture, and I'm not going to get paid for another 2 weeks, but I'm still going to work because that delayed reinforcement, my paycheck, I know will come, and I'm thinking about that, even though it's not an immediate and direct reinforcement. Higher order conditioning can be enabled with cognition. Humans can set behavioral goals for self and others and plan their own reinforcers, right? I have a bullet journal. I know that when I keep a bullet journal and I track things such as if I read every day or if I work out every day, like I'm more likely to do that because I like the reward of being able to draw it in my bullet journal, right? And everybody has different ways of managing that type of stuff, but that's a cognitive process that I recognize works for me, so I'm going to continue doing that. So just kind of think about the cognition involved in this, because we've talked a lot about kind of this like just natural response in classical conditioning and operant conditioning, but there is cognition that is involved as well. So part of that then, in terms of what cognition can do, is this idea of latent learning. And this refers to skills or knowledge gained from experience, but not apparent in behavior until rewards are given. So in the experiment that we're looking at here, basically what happens is they put these rats in like a maze. And there's only one way to get from the the entrance to the exit, right? And there's a lot of dead ends, like we've all been to mazes before. And basically the rats run around and they're like not really all that interested. But once a reward is presented, right, say like a piece of cheese at the exit of the maze, they're very quick to apply the learning that they've done by just kind of running around to find the cheese, right? So the evidence says that these maps revealed once the cheese is placed somewhere in the maze, after only a few trials, these rats quickly catch up in maze solving to rats who were rewarded with the cheese all along. So they learned the maze even though there wasn't an intentional reward that was going to be given to them, right? That's the idea of latent learning. We also know that for like people, there are ways in which we learn through motivation, right? Intrinsic and extrinsic motivation are something that we're going to continue to talk about looking ahead into AP psychology if you were taking it next year. But for now, it's important to recognize that these types of motivations will influence us to take certain behaviors, right? What might happen if we begin to reward a behavior somebody was already doing and enjoying? If you're golfing and then all of a sudden you start paying them for it, the person might lose that intrinsic motivation and might not reliably do the behavior well, right? They might lose that, like, I'm doing this just for fun, and now all of a sudden you're trying to pay me for it. It's not as fun anymore. I don't want to play, right? So intrinsic motivation is this idea that we desire to perform a behavior well for its own sake, just because we like to do it, or because it's fun, or just because it's what we want to do, right? The reward is internalized as a feeling of satisfaction. On the flip side, extrinsic motivation refers to doing a behavior to receive rewards from others, right? Do you golf for fun, just for the enjoyment of getting outside and playing and having a good time? Or are you like Tiger Woods and you golf, obviously he probably enjoys it as well, but also to get paid? So like that's the question here. And we're actually going to do a quick little inventory survey thing that's going to see, are you more intrinsically or extrinsically motivated? So with that, I want you to go ahead and I want you to pause this lecture, and I want you, there are going to be 30 questions, and I want you to rank from 1 to 4, 4 being like yes, a lot like me, 1 being no, not at all. Wow, that I've never written, whatever, you get that. So 1 is no, not at all like me. 4 is yes, always like me. So go ahead and answer these, pause it. Once you're finished with 1 through 15, press play. You'll go to the next slide. Again, 1 is never or not at all like me. 4 is always like me. So fill these out, pause it, and then we'll get our results. Okay, so you filled those out. You have 30 numbers 1 through 4. What you're going to do is you're going to calculate 2 different scores. You might need to pause this slide, that's totally fine. But to find your intrinsic motivation score, you're going to reverse scores for numbers 9 and 14, meaning if you put a 4, you're going to count it as 1. If you put a 3, you're going to count it as 2. If you put a 2, you're going to count it as 3. If you put a 1, you're going to count it as 4. So reverse your score and then add together these numbers. Okay, do the same thing with your extrinsic motivation here. So pause it, find your scores, and then let's talk about what that means. So you've added together, you know your intrinsic motivation score, you know your extrinsic motivation score, and overall we know scores on each subscale can range between 15 and 60, with higher scores reflecting greater intrinsic or greater extrinsic motivation, respectively. So if you have a higher score on intrinsic or extrinsic, you can see, are you more motivated by internal satisfaction or getting some sort of external reward. Mean scores overall for both male and females was about 45 for intrinsic motivation and 39 for extrinsic motivation. When we're looking at this particular survey and what that means for like us and our understanding of ourselves, it says research suggests little correlation between scores on the 2 scales. If you wish, scores on each subscale can be further broken down. If you're interested, you can look at items, ready? Jot these down. Items 3, 5, 9, 11, 13, 14, and 26. Those are going to reflect an orientation toward challenging tasks. Items 7, 8, 17, 20, 23, 27, 28, and 30 will show an orientation towards enjoyment of one's work. And then 1, 2, 6, 12, 15, 18, 21, 24, 25, and 29 reflect an outward orientation toward recognition and dictates of others. So if you're interested to break that down further to get a sense of like what exactly motivates you within that intrinsic or extrinsic motivation, could be kind of interesting. But we're going to kind of move on. But we do want to reference the fact that motivation is a key cognitive process in our decision making. Why do we behave the way that we do based on motivational pushes, right? So then we're going to shift to the big ticket item here, and that's observational learning. Observational learning refers to watching what happens when other people do a behavior and learning from their experience, right? So think about like when we talked in our developmental unit with Kohlberg's stages of morality, right? In the pre-conventional stage, you have these little kids that are like making their decisions based on whether or not they're going to get in trouble, right? And like that doesn't necessarily mean like they have to get punished, but they might be watching other people and seeing like, oh, Jack pushed Susie down on the playground and he had to go in timeout and couldn't have recess for a week. I shouldn't push Susie down because I don't want to get my recess taken away, right? It's kind of similar to that. So just kind of think about this idea that we're learning through more than just this idea of classical and operant conditioning, right? The question that this idea of observational learning begs is, can we, like rats, learn without direct experience, right? We're going to look at mirroring and cognition, mirroring being able to picture ourselves doing the same action, and then cognition is obviously like noticing the consequences, thinking about like above and beyond, why am I behaving this way? And so the processes that are involved here are modeling and vicarious conditioning. Modeling is the behavior of others, serves as a model, an example of how to respond to a situation. We may try this model regardless of reinforcement. I think about like girls learning how to put on makeup. I don't know if this is like just a me thing, but like when they put their mascara on, their mouths go like wide open. Maybe this is a crazy example, but like their mouths open up and they put their mascara on, and then they pucker their lips and put on their blush and their bronzer and stuff. Like, where did you learn that, right? Maybe you watched your mom put on makeup, or maybe you watched, I guess you guys have like YouTube tutorials now on how to like do makeup, but you get the process. You're modeling behavior, right? And then you have vicarious conditioning, which is experienced indirectly or through others, right? Vicarious reinforcement and punishment means our choices are affected as we see others get consequences for their behavior. So it's not just like, if it happens to me, I'll learn, but if I see it happen to somebody else, I'll still learn, right? And so the most significant psychological experiment pertaining to observational learning is Albert Bandura's Bobo doll experiment. And basically we are like, after, I'm just going to briefly introduce this, and then we're going to watch a 10-minute crash course that ties all of this together and gives further insight into the Bobo doll experiment. But basically, kids were shown videos of adults either beating up and like being super aggressive with this inflatable clown doll thing, and getting their aggression out on the doll, or they watched videos of adults who did not do that. And when the kids were put in the room with the doll and a bunch of toys, they were then, they were hanging out there playing, but then the experimenters took all their toys away and they got frustrated. The kids who had seen the adults take out their aggression on the Bobo doll did the same thing. They beat up the Bobo doll, they kicked him, they threw him, they punched him, they tackled him, right? Whereas the kids who didn't see the adults beat up the Bobo doll, they didn't express their frustration in that way. So this is an example of how we kind of can prove or consolidate our understanding of modeling and observational learning. So like I said, we're going to watch this crash course. It's about 10 minutes, but it talks about the Bobo doll experiment as well as classical and operant conditioning, and kind of brings all of this back together. After this video, we have just about 5 more slides to just kind of give a little bit of examples and like tie everything back together.
It's 1961. You're wandering around Stanford University looking for a sandwich or something when you happen to walk by a particular room in a particular lab and see something a little unnerving. Namely, you find a woman punching an inflatable clown named Bobo in the neck. over and over in its neck. This was the lab of legendary psychologist Albert Bandura, and in 1961 he was studying one of the most important phenomena in psychology. See, while that woman was throttling that big inflatable clown, there was a child watching her, and after about 10 minutes of observing this clown-beating display, the kid was taken to a room full of fun toys, which were soon taken away, and then the frustrated kid was left alone with Bobo, and Bandura watched what happened. And yeah, what happened was kinda scary. Kids who watched the woman beating the clown were much more likely to mimic her aggression, kicking, punching, throwing, even attempting to maul Bobo with a hammer. But other children who saw an adult playing nicely with a doll or just ignoring it didn't respond the same way in their frustration. Bandura's results may seem predictable now, but in those days they challenged the dominant behaviorist views that we talked about last week. The views that learning is solely about conditioning and association, rewards and punishments. Bandura's research focused on how learning can occur through observing and imitating someone else's behavior. And if that seems obvious to you, you have Bandura to thank for that. His research hastened the evolution of 20th century experimental psychology from pure behaviorism into what we now know as social cognitive learning. While it was closely related to behaviorism, the social cognitive models added profoundly new dimensions to what Skinner and Watson and Pavlov had observed in our feathered and furry friends. In other words, it showed us that just as there's more than one way to beat up a clown, there's more than one way to learn. Last week we talked about the differences between classical and operant conditioning in associative learning, the kind of learning that comes from connecting different events and stimuli. In classical conditioning, this means associating a stimulus with some kind of involuntary response, the whole dog slobbering at the sound of a bell phenomenon, whereas operant conditioning makes associations between stimulus and a voluntary behavior, like the rat pressing a lever to get delicious snacks or jumping out of a cage to avoid an electric shock. And that's all well and good, but if learning is the process of acquiring and retaining new behavior and information, then Bandura's experiments showed us that conditioning with external rewards, punishment, or other stimuli isn't the only way to do it. It's hard to deny that pretty much all animals are capable of learning certain things by association, but critics of behaviorists like Pavlov, Watson, and Skinner had a problem with their assertions that when it came to learning, it didn't matter much whether you're training rats, pigeons, or people. It's all the same, because lots of research has demonstrated that an animal's capacity for conditioning is actually limited by its biology. Consider this scenario. Say, I get a raging case of food poisoning after eating my head weight in raw oysters with my friend Bernice. I'm probably not going to want to touch oysters again for a long, long time because I associate their smell and taste with the smell and taste that they made when they were coming back out. That's what I'm trying to say. But that doesn't mean that the sight of Bernice or the sound of the sea shanties that they were playing at the restaurant would make me barf, because humans are, by our very nature, more taste averse than we are sight or sound averse. On the other hand, sight-oriented animals like birds may be biologically predisposed to avoid tainted food by sight, since that's how they hunt and forage. And presumably they go to restaurants that play better music. Anyway, all this tells us that species can more easily learn associations that help them thrive or survive, and that not all associations are learned equally. It's a lot easier to teach a pigeon to peck an X on the ground to obtain a food reward than it is to get it to flap its wings to get that same reward, because pecking is a natural foraging behavior for a pigeon. In the same way, it would be much harder for the bird to learn to peck that X to avoid a shock rather than to flap its wings to avoid the shock, because flying away from danger is what pigeons naturally do. Learned associations are even more complicated in humans, of course, because what we learn doesn't only influence our behavior, it also shapes our attitudes. Our cognition, that is, our thoughts, perspectives, and expectations, is important for learning, as is our social context, as Bandura figured out. So Pavlov-style conditioning experiments that ignore those social cognitive elements can really run into trouble. For example, someone under treatment for an alcohol addiction may be given booze laced with a nauseating drug. According to the pure classical conditioning model, that person would then equate booze with feeling nasty. But the brain can override this association if it's aware that the added drug and not the alcohol is the thing that's causing the illness. Sometimes we can think our way out of intended associations. And by the same token, a person's social context, like their friends, family traditions, or life stressors, can reinforce something like alcohol consumption more than the nauseating pill could ever punish it. Plus, we also do a lot of latent learning, like without even knowing it. Have you ever been walking around a new city, someone stops you to ask for directions, and you surprise yourself by actually being able to tell that tourist how to get to the park? That's because we're constantly developing cognitive maps or mental representations of our surroundings without explicitly telling ourselves to do it. We've all seen the experiments with rats in mazes. Well, those show us that even rats develop these cognitive maps, figuring out how to get around even if there's no reward at the end. And days later, when they finally do get food at the end of the maze, they quickly demonstrate all that earlier latent learning by scuttling through the maze as fast or faster than rats that had been rewarded all along. So learning isn't just about associating a response with a consequence. There's thinking happening too. And this kind of thinking is also a big part of observational learning, which is basically learning by watching other people or being influenced by them in other ways. Because you don't need direct experience to learn. You can just pick stuff up through modeling. Not like modeling on the catwalk, I just mean observing and imitating specific behaviors. Rats, crows, pigeons, primates, and other animals learn through imitation. Chimps learn how to use sticks to fish ants out of a nest this way. One study found that rhesus macaques were usually slow to make up after a fight, unless they grew up watching more forgiving older macaques, in which case they tended to make up more quickly. Of course, we humans learn a lot from modeling. I mean, most of our popular culture is based on it. New slang, skinny jeans, foodie trends, pixie cuts, they're all racing around the globe through observation and imitation. So it makes a lot of sense that social observation shapes behavior, especially in children. Which brings us back to Bobo. Again, the fact that we learn by imitating even when we don't mean to seems pretty intuitive. But until Bandura's famous experiment, it hadn't been studied in a scientific way. I mean, these kids started abusing Bobo not just with little toddler punches, but with hostile language and even using things like toy guns that they'd previously had no interest in. And all because they saw aggressive modeling in action. And since Bandura's time, technology has allowed us to peer even deeper into this dynamic. Neuroimaging in humans, for instance, has shown that when an individual watches someone else, especially someone whom they relate to, receive an award or score a goal or something, their own brain's reward systems light up vicariously. Italian researchers found this out pretty much by accident in the early 1990s. They were studying signals from key regions in a lab monkey's brain that were associated with planning and doing. Their brain monitoring device buzzed softly when the monkey did something like pick up a piece of fruit and eat it. But one hot day, a researcher came back from lunch licking an ice cream cone and suddenly heard the animal's brain monitor buzz. The monkey was watching him, and his brain worked as if he was actually doing the licking. Many scientists suspect that this is the work of a previously unknown type of brain cell called mirror neurons, which fire when a subject both performs an action and when they observe someone else doing it. Mirror neuron research is still relatively new, and we're still figuring them out, but combined with Bandura's earlier work, it's revealing a strong connection between observation, imitation, and learning. So the takeaway here is models are important, and not just Giselle and Antonio Sabato Jr. You can, if you want, observe and imitate them. I'm just saying that observational social learning starts really early, and parental figures are powerful role models. Positive, supportive, and loving models usually prompt similar behavior in others, just as negative, aggressive modeling can spark antisocial effects. And as we'll talk about later, what we see and feel and learn as children is not easily displaced when we're adults. Literary giant George Bernard Shaw wrote, "Imitation is not just the sincerest form of flattery, it's the sincerest form of learning." And British statesman Lord Chesterfield once said, "We are, in truth, more than half what we are by imitation." Even if these ideas were only half true, they'd still be a powerful lesson on who you choose to spend your time with and how you choose to act. If you learned anything by watching me today, hopefully it involved the limitations of classical and operant conditioning, the basics of cognitive, observational, and social learning, a look at mirror neurons, and how to beat up a Bobo doll. Thanks for watching, especially to all of our Subbable subscribers who make this whole channel possible. If you'd like to sponsor an episode of Crash Course, get a special decal, or even be animated into an upcoming episode, just go to Subbable.com. This episode was written by Kathleen Yale, edited by Blake DiBastino, and our consultant is Dr. Ranjit Bhagwat. Our director and editor is Nicholas Jenkins, and the script supervisor is Michael Aranda, who is also our sound designer, and the graphics team is Thought Cafe.
So hopefully that gave some further insight, big picture about this learning unit. We are going to just look at some of the specifics. Now, you don't really need to know some of these like specific details, but you will want to recognize like what mirroring is big picture, pro-social and anti-social effects, again, big picture. So we'll just talk through it, and then we'll be done with our learning chapter. So when we talk about mirroring, this is basically when we watch others doing or feeling something, neurons fire in patterns that would fire if we were doing the action or having the feeling ourselves, right? These neurons are referred to mirror neurons, and they fire only to reflect the actions or feeling of others. So if you see somebody in pain, your brain will fire neurons that make you feel uncomfortable, that might like make your stomach drop, right? That like reflect pain that you're seeing in somebody else, right? That's kind of this like empathy idea. This particular image below of pain and empathy in the brain of the person empathizing or mirroring the feelings of another are firing in some of the same areas as the person experiencing pain. Notice that the areas are more closely related to the emotional anguish than the physical sensations. That sensory strip is not firing in the empathizer. And generally speaking, this mirroring can be involuntary, which leads to emotional contagion of moods and attitudes spreading from one person to another. You've experienced this before. If you're cranky or if somebody near you is cranky, it makes you cranky. While that's a very oversimplified example, right? It's true, they've done research and they have brain imaging to show that these mirroring neurons do in fact empathize and fire in the same areas of what you are seeing somebody else experience. When it comes to like differentiating between mirroring and imitation, we know that humans are prone to spontaneous imitation of both behaviors and emotions, and this includes over-imitating, that is, copying adult behaviors that have no function or reward. So you can see in this picture, right, baby's looking at adult, baby sees adult look at creepy doll thing, baby then also looks at creepy doll thing, right? And so this is one piece of kind of the puzzle of how we learn. We imitate, especially young children. One thing that people have studied is the effect that this has on children with autism, and they found that children with autism are less likely to cognitively mirror and less likely to follow someone else's gauge, as a neurotypical toddler is doing in this particular image. Like, this child does not have autism. The baby follows the sight line of the adult that she or he is looking at. But babies who have autism generally aren't going to be doing that. So just kind of recognizing mirroring, imitation. Imitation is generally like a younger phenomenon, but that doesn't mean that it doesn't continue to exist in some facet as we continue to grow older. Then we're going to add this idea of vicarious reinforcement. So not only is our brain firing neurons that like stimulate or simulate what we're seeing, but we also compare that then with our understanding of vicarious reinforcement, this idea that Jack pushed Susie down, Jack got in trouble. If I push Susie down, I'll also get in trouble, right? We know that mirroring enables observational learning because we continually practice a behavior just by watching it. If you combine this with vicarious reinforcement, we are even more likely to get imitation. Monkey A saw monkey B getting a banana after pressing 4 symbols. So when monkey A then pressed the same 4 symbols, even though the symbols were in a different location, they also got a monkey, right? A banana. So recognize that this can be a pretty powerful force above and beyond our conversations about operant and classical conditioning. So with that then, we'll shift and say, like, what are the ramifications of this? What are the effects? There can be pro-social behavior, meaning that some kids can learn or mirror or imitate or vicariously condition to engage in actions that benefit others or contribute value to groups and follow moral codes, right? Parents try to teach this behavior through lectures, but it's most commonly taught through modeling, right? If a parent says, stay off your phone, but then is on their phone all the time, the kid is going to probably disregard what the parent says and instead follow the model of what the parent is doing, right? Especially young kids. But with that said, there are also antisocial effects that observational learning can have on children as well. So when we talk about this antisocial behavior, we're oftentimes referring to children who witness violence in their homes but are not physically harmed themselves, may hate violence but still may become violent, right? This is basically saying, like, kind of like the Bobo doll experiment. If you see violence and you see aggression being taken out in a physical manner, regularly speaking, when you're faced with a stressful situation, you might respond in the same way, even if that violence wasn't directed towards you, but it's what you saw and it's what you kind of learned from, right? So these are, right, you have pro-social and antisocial effects of observational learning. And then the last piece of it here is thinking about what does that mean for like the media model of violence. Do we learn antisocial behaviors from like movies, TV shows, and social media? Generally speaking, research shows that viewing media violence leads to increased aggression and reduced pro-social behavior. And this violence viewing effect might be explained by imitation, but also desensitization toward pain in others, right? The more you see people getting harmed, right, the less shocking it is to you and the more likely you are to not think it's that big of a deal. And this is kind of a change that occurs over a period of time. It's not like you see one person get beat up in a TV show that like you're immediately like, oh, I don't care about the well-being of others, right? Like this is a long process and you don't necessarily recognize that it's happening. So with that, that brings us kind of to the end of our conversation about learning. Again, we talked classical conditioning and operant conditioning in this kind of cognitive approach, this observational learning, the fact that like we also have a say in what we think and why we do the things that we do, kind of aims to bring all of this together and help us understand human behavioral patterns overall.